The Big Bang Theory is the most widely accepted scientific explanation for the origin of the universe. It suggests that in the beginning, all the matter and energy in the universe were concentrated in an incredibly small space, smaller than a grain of sand. Then, suddenly, a rapid expansion occurred, giving rise to space and time as we know them. The Big Bang Theory states that there was no before, as it was from this event that our universe originated. However, the question of what existed before this event remains open. What if the Big Bang wasn't truly the beginning of everything? What existed before? Roger Penrose, the 2020 Nobel Prize winner in physics, has questioned the Big Bang Theory, proposing an alternative cosmological model. According to Penrose, the current universe might have been generated from a previous universe, and traces of this past universe may still be visible in our own. If the Big Bang didn't create our universe, how did it form, and what evidence can we find of that prior universe? Penrose is a highly respected mathematical physicist, and he developed his alternative theory alongside other scientists, including the astrophysicist Stephen Hawking. The model proposed by Penrose is known as Conformal Cyclic Cosmology, and it seeks to answer questions that the Big Bang Theory cannot fully explain. To understand why Penrose does not accept the Big Bang Theory, it's helpful to clarify what a scientific theory is. Often, people think of scientific theories as mere hypotheses invented to explain physical phenomena. But that's not the case. A scientific theory is based on observations, measurements, and experiments, and it is capable of making precise and verifiable predictions. The Big Bang Theory wasn't a random idea from a scientist who woke up one day and decided that the universe began this way. It is a solid cosmological model, developed over decades, based on Einstein's theory of relativity and continuously supported by astronomical observations. In 1929, the astronomer Edwin Hubble observed that the more distant galaxies were moving away from us faster, a phenomenon that confirmed Einstein's prediction of an expanding universe. This means that, if the universe is expanding, going back in time, the universe must have been smaller, to a point where all matter and energy were concentrated in a tiny space called a singularity. Another important piece of evidence is the 1964 discovery by astronomers Arno Penzias and Robert Wilson of the cosmic microwave background radiation, a faint glow left over from the Big Bang that permeates all space. Despite the strength of the Big Bang Theory, it has limitations. The question, what was there before the Big Bang, has no satisfying answer within this model. In fact, according to the Big Bang Theory, time itself began with the initial expansion, so it makes no sense to speak of a before. The very concept of time and space, according to this theory, did not exist before the Big Bang, making the question unanswerable within this framework. Roger Penrose, however, proposes an alternative view to try to solve this puzzle. According to him, not only can we not talk about before the Big Bang, but we can also think of the universe as part of an infinite cycle, where the universe doesn't come from nothing, but from a previous universe, in a continuous cycle. Penrose proposes Conformal Cyclic Cosmology, a model suggesting that the universe has no absolute beginning or definitive end, but goes through cycles of birth, evolution, and death. Each life cycle of a universe is called an eon, and the end of one aeon coincides with the beginning of the next. This model implies that before the Big Bang, there was another universe that disappeared in the past, and after the end of our universe, another one will follow. In this model, the universe expands infinitely, but there is no big crunch or collapse of the universe onto itself, as hypothesized by other cosmological theories. A key concept of conformal cyclic cosmology is the principle of conformal geometry, which allows for the transition from one eon to the next. Conformal geometry refers to the property of shapes that remain unchanged regardless of their size. Think of a chessboard. Whether it's large or small, the rules of the game don't change. Similarly, in conformal cyclic cosmology, there is no distinction between the beginning of a new aeon and the end of the previous one. It doesn't matter how big or small, hot or cold the universe is. What matters is that space-time preserves its fundamental characteristics, allowing the cycle to continue. According to Penrose, the idea that the previous universe leaves traces in our own is supported by the cosmic microwave background radiation, which could contain spots due to phenomena that occurred in the previous universe, such as the evaporation of black holes. The cosmic microwave background radiation shows signs of these spots in particular areas, which could be proof of a link between successive eons. This theory would be confirmed by the detailed map of the cosmic microwave background obtained by the Planck Space Telescope, which captured images of the young universe. However, Penrose's conformal cyclic cosmology is not yet widely accepted. Some cosmologists question the interpretation of the spots in the cosmic radiation, suggesting they could be explained by different physical phenomena. Additionally, the concept of a universe that goes through infinite cycles without a definitive end, where entropy decreases during black hole evaporation, remains controversial, and it has not yet been possible to provide direct evidence supporting these ideas. The Big Bang theory, despite its robustness, cannot answer all the fundamental questions about the origin and fate of the universe. Alternative theories, like Penrose's, offer a chance to think about new possibilities and scenarios that could be more complete or simply more compatible with future observations. However, the lack of empirical evidence for conformal cyclic cosmology makes it difficult to accept as a full-fledged scientific theory on par with the Big Bang, which remains the best explanation available for the origin of the universe. In any case, scientific research is constantly evolving, and the discussion between alternative theories and established models is a fundamental part of the progress of knowledge. The important thing is to keep an open mind and continue exploring the universe with scientific rigor and curiosity. Thanks for watching. Leave a like, subscribe to the channel, and hit the notification bell so you don't miss future videos.